Okay, see here in that way we are going to find out the thermal efficiency for regeneration cycle. Uh, you may not know how much improvement of thermal efficiency by knowing the theory. While doing problems, you come to know that how much efficiency difference in between general Rankine cycle and regeneration cycle. Okay, I will let you know then. Now we will go with another efficiency improvement cycle, which is reheating cycle. Previously what we have done after expansion we have extracted some of the steam to heat the feed heaters, but here what we are doing was in reheat. 1 minute please. Okay, in reheating what we are going to do was here we have extracted some of the heat, but here what we are doing was uh, here what in reheating what we are going to do is after expansion. Okay, after expansion the whole after some expansion the whole steam has been extracted here. Okay, in regeneration we have extracted some of the steam to heat the feed heaters, but here the whole after certain expansion the whole steam. Okay, in regeneration we have taken part of the steam, but here in reheating we are going to take the whole steam. We are going to take whole steam, that again from boiler we are going to give that to the turbine, and from turbine we are allowing the steam to expand, and after expansion, after certain expansion we are going to take the whole steam. We are in regeneration part of the steam has been taken, but in reheating the whole steam has been taken. That is the main difference between regeneration and reheating. After taking the whole steam, there will be some intermediate pressure, high pressure turbines are going to be there. From that high pressure turbine, the outlet of this turbine is sent and again into this heater here. Okay, so by using some of the source, there will be heaters here. By sending this to here, again we are going to raise the temperature of this steam here. So after we have expanded here, we have taken the whole steam and again given to the heater, and that means we are going to raise the temperature of the steam, and again we are going to feed that to the turbine here, and again we are going to uh, allow that for expansion. See here two types of we are going to have two turbines here. One is low pressure turbine and the other one is high pressure turbine. First of all we give the steam to the low pressure turbine, and again that will be taken to heater, and at heater we are going to again increase the temperature and again we are going to give back that to the turbine. That's what reheating. See, we are going to heat the steam two times. One is first thing at boiler, and the second time we are heating at reheater heater. Okay, so this is one heating, and again we are going to heating. That is nothing but reheating. That's why we are going to call this process as reheating process. If we do like so, then we are going to have or achieve high efficiency when compared to the general Rankine cycle. Okay, so in that way we are going to use the reheating cycle. So remaining all the procedure is same. Only the thing is we are first of all we are going to increase the pressure within the boiler. That means sorry, at constant pressure we are going to change the phase that has been allowed taken to the turbine, and after certain expansion the whole steam within the turbine has taken to again heat. Okay, so we are going to use or giving heat input two times. One is at boiler and the other one is reheating at boiler and reheating with heater. That's why we are going to call this as reheating. So again after reheating we are taking back that whole steam to the turbine here, right? So after expansion there will be some work output, and after doing some work there will be some low pressures here, and with that whatever the back pressure or low pressure from the output of the turbine is there, that has been taken by the condenser here, and again the same process within the condenser there will be change of phase with the help of some cooling water circulation. and again there will be change of phase from vapor to liquid, and that liquid or water is taken to pump here, and from pump again we are going to feed the boiler with this feed pump. Okay, so that is what reheating. Simply the main thing here in between regeneration and reheating is, here we are going to extract some of the heat, and but here we are going to take whole heat and again we are going to reheat here. That's the main difference. But here in regeneration we are going to heat before taking that to turbine only. Okay, here with feed heaters we are going to heat some temperature to raise its temperature liquid, and at boiler there will be phase change, and with the help of superheater we are going to raise the temperature of steam. But here we are allowing it to expand it in turbine. After expanding it, after allowing it for expansion in turbine, taking whole steam to the heater, we are reheating here with the heater, and again sending to the turbine and allowing to do some work. That means there will be work output here after this thing. Okay, and here after that whatever the thing we have got, that has been taken to the condenser, and again the same procedure within the region, normal cycle is there now, that has been taking place. Okay, now in this for this reheating cycle we are going to draw TS and HS chart. This is the TS chart and this is the HS chart. In TS chart, particularly what the things has to be uh, shown clearly: temperature on y-axis and entropy on s-axis. That means the changes in temperature and entropy has been shown clearly. So this is vapor dome. It was not completely given. This is going to be the vapor dome here. Okay, this is the vapor dome. It should be like this. Okay, it should be like this, the vapor dome, or else like this, but it has not given. Okay, this is the vapor dome. We have discussed that during general Rankine cycle. Okay, vapor dome is going to be there. So the process we already know the process from here. So uh, first of all, this is inlet to the boiler, that is 6, and outlet of the boiler has been given to the turbine, that is process 1. And again here we are going to take heat giving to the heater, we are going to take that as 2, and again taking that 2 uh, from at enthalpy H2, we have taking, we are heating that, and whatever the output we have is H3, and that H3 and some amount, whatever the amount of steam we have taken, that has been fed to the turbine here. And after doing some work we will have the H4 state 4 here, and given to the condenser. After there will be change of phase, and there will be some reduction in temperature, that has been taken as H5, and that is input to the pump, and the output of the pump or inlet to the boiler is going to be H6 cycle. Okay, here we are going to have two pressures. This is inlet pressure and this is outlet pressure, and this is intermediate pressure. Okay, see, previously in regeneration and reheating we had only two pressures. One is turbine boiler pressure and the other one is condenser pressure. But here, since we are going to use two heat inputs, one is boiler and the other one is heater, right? So that's why we are going to have two inlet pressures. One is this is one inlet pressure, and this is another inlet pressure. We are at heater. This is the inlet pressure. That means this is boiler pressure. This is heater pressure, and this is condenser pressure. We should know in that way. Okay. This is or else we can say this is input pressure. This is outlet pressure, and this is intermediate pressure. Why? Because here we are going to have low pressure turbines and high pressure turbines respectively. So here another input is there now, that's why we are going to give this as another some other low pressure here. Okay, so this is inlet pressure, P2 is intermediate pressure, and P3 is condenser pressure, right? So this P1 we already know, this is the process from 6 to 6 to 1. Okay, from boiler output to the boiler input, heat addition process. Okay, okay, this is heat addition at the boiler here, and again here we are going to have isentropic process. Okay, here within the turbine, what we are going to have, some isentropic expansion is going to be there. So S1 is equal to S2 here. Okay, isentropic we are going to give, and after certain expansion what we have done, we are again fed that to the heater. So that feeder, in that feeder what we are going to do, we are again going to give some heat input. So this is also heat supplied only. Okay, this is also q in only, this is also q in only. What is this, at which this q inlet is going to be at boiler. Okay, and this heat input is going to be at heater. Okay, and again we are going to have we have fed that to the turbine, and again what happens within the turbine, again some isentropic expansion is going to be there. So if there is isentropic expansion from here, so it will be from S3 is equal to S4 here. Okay, so S3 is going to be equal to S4 here. So since it is isentropic expansion within the turbine, so see here, this is one work output is going to be there, another work output is going to be there. Okay, so there are two inputs, so there are two heat inputs and two work outputs. Okay, see, you should clearly know that one is here. Okay, this is one heat input, this is one heat input, and this is one work output, this is also work output. So we are going to have two work done by the turbine. This is work done by the low pressure turbine, and this is work done by the high pressure turbine. We can use two turbines here. Okay, so inlet of this turbine and outlet of this turbine is given to this, and whatever the heater is there, that has been given to the high pressure turbine, and output of high pressure turbine is given to the condenser. Okay, now while discussing problems, I will let you know by drawing two different turbines here. Okay, so let us be, uh, be clear here itself. Okay, so this is the output and this is the input. Okay, this is the output given to the heater. If there are two turbines, this is low pressure turbine and this is high pressure turbine. This is outlet of this low pressure turbine is given to heater, and again this output of heater is given to the input of low pressure turbine, and from this it has been given to the condenser. Okay, in that way also we can show the, by using two turbines also we can show reheating here. Okay, this is the part. 2 minutes. Okay, so this is isentropic process, that is, which is S3 is equal to S4 here, right? And again this is, what is this process, from 4 to 5 condenser pressure, from condenser pressure this one, and after that we are going to have the process which is going to be at the pump. Okay, what is pump? Sorry, isentropic pumping process. Okay, that is 5 to 6. Okay, that's today we close with this one. If you have any doubts, please raise your hand, otherwise you can join the next class.